Hi there, I'm Buono. Today I want to talk about how to make custom parts in Fritzing. First, a quick word about who I am. I go by Buono, and by day I work as a hardware engineer. These days I post about electronics and technology. Things I've built in my own time include Mimi, a gadget that watches over a child by sound, and Cocktail Cube, an ice cube-shaped gadget that fills a room with the color of a cocktail. As for design software, I'm a longtime user of KiCad, Fritzing, and LT Spice. So here I'd like to talk about Fritzing. So what is Fritzing? Put simply, it's circuit design software. There are three main things it does. You can draw a schematic, you can draw a breadboard diagram, and you can draw a PCB layout. So it covers the whole of circuit design. There is a lot of circuit design software out there, but Fritzing is the only one that draws a breadboard diagram. So if you use breadboards a lot for prototyping, I'd strongly recommend Fritzing. You'll see it as soon as you try it. It is remarkably good. The UI is excellent, it's pleasant to use, and it keeps your project moving. There is one thing that falls short, though. It ships with a parts library, but the lineup is a bit thin, and the part you want often isn't in there. When that happens, you have no choice but to make it yourself. So here I'd like to explain how to make a part. Right, let me explain how to make a custom part. There are two ways to get a custom part. The first is to download one off the internet. The second is to build it yourself from scratch. I'll go through them one at a time. First, downloading one off the internet. If the part you want isn't in the parts library, this is the first thing to try. In many cases, somebody has already made the part themselves and put it up on a page on GitHub or somewhere like it. If it's up there, you're in luck. It saves you making it yourself, so I'd recommend searching the internet first. You only have to download it, so it's about as easy as it gets. Let's try looking up a Fritzing model for the ESP Room 02. When you search, put Fritzing after the module name like this, and if somebody has made one, it usually turns up. Searching like that, here we have a GitHub page for the ESP Room 02 right at the top. Let's open it and take a look. There are several models here, as you can see, so you can tell somebody has gone and made them. Any of them will do. I'll take the simple version, this .def.pd file, which is the extension Fritzing uses. Let's click that file and download it. When you click on the file you've downloaded, it's a little hard to make out at this size, but you can see a part called ESP Room 02 Simple Breakout has come in, and there it is on the breadboard. The traces are all drawn properly, so it works as a Fritzing model. The schematic is in there too, and so is the PCB model. So that's how to download a model off the internet. Once you find one, the rest is easy, so try this first. Next, how to build a part yourself. Finding one online is the best case, but if you can't find one anywhere, you have to make it yourself. It's a step harder than downloading one, but once you've learned it, it's easy, so do take the chance to learn it now. Let me run quickly through how you make a part yourself. The flow splits into three main stages. The first is creating the images. There are four kinds of image: the part itself, the schematic symbol, the PCB layout, and the icon. You make those four images. That said, you don't have to prepare all four. For instance, the PCB layout. If you're not doing board design in Fritzing, you don't need to make it at all. And the icon can just reuse the image you drew for the part itself, so I don't think you need to draw that separately either. So here I'll make the image of the part itself for the breadboard view and the schematic symbol for the schematic view. Once the images are done, you register the image data in Fritzing, and finally you name the pins and assign the pin numbers. That's it. As for what you need, the images have to be made in the SVG format, so you'll need a piece of software that can write that out. For example, Inkscape or Illustrator. I normally use Illustrator, but it costs money, so here I'll use Inkscape, which is free, and walk through it simply. As for how long it takes, the first time may take you a while, but for something simple, once you're used to it, 10 minutes should do it. Right, let's make a custom part. So what are we going to make? Here I'll make a color sensor called the TCS 3200. I wanted to use a color sensor in a gadget I built a while back, but it wasn't in Fritzing's parts library by default, so I made it myself. I'll base what follows on that. Once you've settled on a part, look at the real thing, or the data sheet, and get hold of an image. The documentation is here, so let's look at that. There's a photo here, so I'll use it as a reference and draw in Inkscape. This is the actual Inkscape drawing. The model number here is text, and these labels are text too. GND, OE, LED, and so on. Everything else, the pins, the LEDs, the sensor part, and the board, is drawn from circles and rectangles. It's worth matching the real dimensions as closely as you can because it makes the breadboard diagram easier to picture later, so do match them. In the case of this color sensor, the size was written here in the documentation. So I've made it 28.4mm on both sides. The positions of the other parts aren't accurate. This here, against the real thing, I've laid it out like this, roughly by eye. So it isn't exact, but if all you want is a breadboard diagram and a schematic, you don't need to match it that closely. So placing things roughly at this level is fine. That said, if you're doing proper board design, you do need the pin spacing to match the real part, or the component won't fit. So for board design, draw to the real dimensions. Once you've drawn the image in Inkscape, you export it. But there are two things to do first. The first is to fit the canvas size to the size of the drawing. By default, the canvas is made enormous, and if you import it as it is, then in Fritzing, it gets recognized as an enormous part. So before exporting, fit the canvas to the size of the part. And how do you do that? You go to File, then Document Properties. And here there's a button called Resize Page to Drawing or something along those lines. Press that, and then it's a bit hard to see, but the canvas fits itself to the part. The other thing you have to do is convert the text to outlines. If you don't, then in Fritzing, when you load this image, the text doesn't come in correctly. The font size can come out enormous, so rather than leaving it as text, you need to outline it so it comes in as shapes. To do that, select the whole drawing, then go to Path and choose Object to Path. Pressing that turns all of the lettering into outlines as well. That done, we can export. Here I'll save it under the name Color Sensor New. Now let's load that image into Fritzing. So, registering the part. There are a few ways to go about it. One is to build it completely from scratch. The other is to take a default part and modify it. I'd recommend the latter. Working from a part that's already in Fritzing means fewer mistakes, so that's what I'd suggest. It's what I always do. I always base my parts on this generic IC. The model for this IC lets you change the number of pins freely, which makes it easy to customize. For this color sensor, there are 10 pins, so I'll set the IC to 10 pins. That gives us 10 legs. Naturally, at this point, it still looks like a plain DIP package IC, and the schematic is nothing but pins numbered 1 through 10. The pins come out of each of those legs like this. That's the model as it stands. So let's replace it with the color sensor. The way you do it is to right-click and click Edit, New Parts Editor. That brings up the Parts Editor window. There are several tabs. This is the image used on the breadboard. Then there's the schematic, the PCB, and the icon that shows in the library. Let's start here by changing the breadboard image. You press Load Image for view here and load the SVG file we saved earlier. Right. There we are. The image has come in. The next thing to do, at this point, it's still just an image file, so we need to register which pin is assigned to what and where. There are 10 pins here, so I'll set them one at a time. The pins run from 1 to 10, but which one is pin 1 and which is pin 2 isn't fixed for you. So as long as you're consistent with yourself, you can decide it however you like. Here I'll number them 1 to 10 going clockwise. As for how, first select pin 1, then click Select Graphic. After that, choose the shape you want to assign it to. When you left-click here, you'll see a cross appear, like this. That means the pin has been assigned. Then you carry on doing the same for the rest. Right. That's all 10 pins assigned in the same way. Let's save it in this state and see what we get. Go to File and choose Save as New Part, and then you give it a name. The name can be anything, so choose something that will make sense to you later on. Here I've called it Color Sensor New. Back in the Fritzing window under the Mine tab, the part we just made has been added, so let's take a look. I haven't changed the icon yet, so the old image is still showing, but if I drag it out, you can see the image we made comes up. And because we assigned the pins, each of those shapes is recognized as a pin, so you can run wires to them. Next, while we're here, let's change the icon as well to the color sensor image we made. The same way as before, open Edit, New Parts Editor, and click the Icon tab. This part is very easy. Under File, click Reuse Breadboard Image. That says use the breadboard image we just made as it is, so it just copies it straight across. Then we press Save. This time it's an overwrite. Back in the Fritzing window, as you can see here, the color sensor image is now in the icon view. Right, next, let's make the schematic symbol. By default, it's just a simple symbol with pins 1 to 10, like this. That makes it hard to tell which pin does what, so let's give each pin a name. I'll name 1 through 10 in the order we assign them. One thing to note, you can't change the labels on this screen. As before, you type the labels in Inkscape or whatever software you use to make the SVG. Keep that in mind. You could draw this symbol from scratch in Inkscape, but there's a base image here, so I'll take the approach of editing that instead. To do that, go to File and choose Show in Folder. That takes you to the folder holding the raw files of the parts library that ships with Fritzing. I'll copy this and then rename the copy. Then in Inkscape, open the file we just saved. Then on this screen, I change the labels 1 through 10. Right, all 10 labels are on. Again, before exporting, fit the canvas size and don't forget to convert the text to outlines. Now let's open the image we just made. On the schematic side, there we are. The image has come in with the labels on. Right, let's save this again. And if we put a quick circuit together in Fritzing, there we are. Each pin on the IC has its label, and you can see each leg is recognized as a pin. And that's it for custom parts. Some of you will do board design in Fritzing too. If so, add the image on the PCB tab in the same way and assign the pins there as well. There's also something called metadata. That's where you register information about the part, and you can register a part without touching it. But if you want to make your custom part properly, have a play with it too. So that's how to make a custom part. To sum up, Fritzing is genuinely good circuit design software, and being able to draw a breadboard along with an easy UI is what sets it apart. Custom parts are easy to make, as I've shown here, so do give it a try. Remember, search the internet first, and if it's not there, make it yourself. And that's it for today's video. On this channel, I focus on electronics and technology and post what I learn. If that sounds like your thing, please do subscribe. And if there's a video you'd like me to make, or something here that wasn't clear, please do leave a comment below. That's it for today.